Hi, welcome to your very first video for Advanced Algebra. Today we're going to talk about lesson 1.1, and that lesson is about the language of algebra. A couple of vocab words we're going to start out with today. First one is the algebraic expression. An algebraic expression is an expression with numbers or numbers and variables that does not have an equal sign. So that would be the key. It doesn't have an equal sign. As you can see, I've filled that part in. So how is that different from an algebraic sentence? Well, the clue would be that equal sign. So an algebraic sentence is an expression with an equal sign or an inequality sign. So an expression with an equals or inequality sign. And if you look at this blue box here, those are all the different signs that you would see that would help you understand that it's an algebraic sentence, not an algebraic expression. Underneath the triangle and down below here you have the area formula, and this is an algebraic sentence because you see an equal sign right there. And also the volume formula, you have an equal sign, so that is an algebraic sentence. We're going to practice writing some algebraic expressions and sentences. In this first example, Joseph has a collection of 1,380 comic books and buys 17 new titles every month. If Joseph continues collecting comic books in this way, how many comic books will he have after M months? So we're going to write an expression that shows this algebraically. So Joseph has 1,380 comic books, and he's going to buy 17 new titles every month. So the and tells us that it's plus. So plus 17 new titles every month. So we need to multiply that 17 times m, where m equals months. That is an algebraic expression because there is no equal sign. 1380 plus 17m. Let's practice with another one. Maria collects stamps. She already has 860 stamps in her collection. She plans to buy 20 stamps each month. How many stamps will Maria have after M months? So Maria has 860 stamps, and there's an and. She plans to buy 20 stamps each month. So and means plus. She plans to buy 20 stamps each month. So 20 times M. M equals months. So she has 860 plus the 20 more each month she's going to buy. And that is the algebraic expression. The next part we're going to talk about in this lesson is evaluating expressions and formulas. So to evaluate expression, what that means is you're going to substitute numbers for variables in an expression and calculate the results. I wrote that definition in the box on the left here. So evaluating the expression, just substituting those numbers in for the variables and getting the results. There are rules for the order of operations that you have learned in algebra that we're going to review in advanced algebra, and because we use those constantly. The first one is you need to perform operations within parentheses or other grouping symbols from the innermost group out. In other words, you move from the inside out. So inside to the outside. The next rule that you need to remember is you must take powers from left to right, multiply and divide in order from left to right, and add and subtract in order from left to right. It's just like reading a book. You always go from left to right. So powers meaning exponents, left to right, make that a fancier L, multiply and divide, left to right, and add and subtract, left to right. Remember those order of operations if you learned it as PEMDAS? We do parentheses, exponents, multiply, divide, add, and subtract in that order. And that'll help you remember the order of operations. We're going to practice two examples using that order of operations. The first one, example 2a. Find the value of this expression when a equals 3, b equals -1, and c equals -4. So we're going to plug in those values in for the variables. So it's -b, and b is -1, so negative times the -1 minus the square root of b squared, so -1 squared minus 4 times a is 3, and c is -4. Square root of that all over 2 times a is 3. Let's simplify that some more. A negative times a -1 would be a +1, same as a -1 times a -1, minus the square root of -1 squared, we're going to move from left to right, would be 1, minus, and we're going to do these parentheses, move from left to right. So -4 times 3 is 12, times a -4 is -48. Divided by 2 times 3 is 6. Let's simplify it some more. We still have 1 minus a -48 would be or 1 minus a -48 would mean plus 48, so you would have 1 minus the square root of 49 all over 6. Square root of 49 is 7, so 1 minus 7 over 6. 1 minus 7 equals -6 over 6. Divide that out, you have -1 as your answer. Example 2b. Find the value of this expression when you have a equals 5, b equals 6, and c equals 4. So we have 2 times a squared, so 5 squared, minus c, they say, is 4, so 4 squared, plus another c, which is 4, plus square root of b squared, b is 6 squared, minus a is 5 squared, plus c squared, c is 4 squared. Okay, let's clean that up again. We'll move from left to right. But we have to handle inside the square roots first. So 2 times the square root of, we know 5 squared is 25, minus 4 squared is 16, plus we still have the 4, plus 6 squared is 36, minus 5 squared is 25, plus 4 squared is 16. We can clean that up some more. We'll go up here. 2 times 25 minus 16 is 9. So 2 times the square root of 9, plus 4. We can't forget that 4 we have out there. Plus, let's work inside this square root. 36 minus 25 is 11, plus 16 is 27. Let's clean that up some more. 2 times the square root of 9, the square root of 9 is 3, so that would be 6, plus 4, plus the square root of 27. You can clean that up some more and say 10 plus 3 times the square root of 3, because 27 is the same as 9 times 3, and we can take the square root of 9 and move that outside of the square root symbol, and we're left with a 3 inside. So this would be the answer to example 2b. Okay, next we're going to talk about equations and formulas. So what would the difference be between the two? Well, an equation is a sentence stating that two expressions are equal. And a formula is an equation stating that a single variable is equal to an expression with one or more different variables on the other side. Okay, I filled that in that box there, so make sure you write those two definitions down, an equation and a formula. Let's give some examples of, it's supposed to say equations and formulas. Okay, an example of an equation and a formula would be x equals b plus or minus b squared minus 4ac all over 2a. That would be an equation and a formula, an e and an f. Another equation and a formula would be a equals pi r squared. That's an e and an f, an equation and a formula. Another one would be y equals 3x plus 4. That's an equation and a formula. Both of those say, or all those examples show that it's a sentence that has two expressions that are equal. The a equals something on the other side, like pi r squared. The y equals 3x plus 4. They're also formulas because you have a single variable on one side that's equal to an expression on the other side that has one or more different variables. So the a equals something on the other side that has a different variable other than a in it. That's what makes it a formula. X equals 15, however, is an equation, but it is not a formula because it does not have any variables on one side. It only has a variable on one side of the equation, but not both. Let's do two more examples about equations and formulas. So the first one, example 3a. A kilowatt hour is 1 kilowatt of power used for 1 hour. What does it cost to have a 60-watt bulb turned on for 33 hours at a cost of 9.53 cents per kilowatt hour? So let's move this up a little bit. Okay, so we can write cost equals 60 watts times the number of hours, 33 hours, they give us that, times the cost per kilowatt hour, and 9.53 cents per kilowatt hour. And we can also abbreviate that as hour. Well, the problem is here we have kilowatts and watts in this problem. So we need to change 60 watts to kilowatts. So we use a conversion. We say 1 kilowatt is 1,000 watts. Just like the conversions whenever you have the K, the kilo with the normal. And we're going to multiply that by 60 watts. We cancel out our watts, so we know our units are going to be kilowatts. So we're left with 60 over 1,000, and we're going to have kilowatts as our units. And that equals 0.06 kilowatts. So we're going to plug that back in, and we can say cost equals 60 or 0.06 kilowatts, because we converted it to kilowatts, times 33 hours times 9.53 cents per kilowatt hour. Now all our units match up. We have kilowatts and hours. So if we do the multiplication, we have 0.06 times 33 times 9.53. If we cancel out our units, the kilowatts are going to go away, the hours are going to go away, and we're going to be left with cents. That's how we know our units. And we should get 18.87 cents. That would be our answer. Then it says give a formula for the cost in terms of the three numbers in the problem. So we're going to give a formula for the cost in the terms of those three numbers, that's 60, the 33, and the 9.53. So we can say cost, which would be total cost, is going to equal P, which stands for power, and that's in watts, because that's the power of the light bulb, times T, which stands for time, in this case months, hours, and times U, which is a unit cost of 9.53 cents per kilowatt hour. So cost equals P times T times U. Let's work this through this last example. It's very similar to 3A. A 15-watt energy-saving spiral bulb produces the same amount of brightness as a regular 60-watt bulb. What does it cost to have a 15-watt bulb turned on for 33 hours at 9.53 cents per kilowatt hour? Okay, I started the problem ready, and I put cost equals 15 watts times 33 hours times 9.53 cents per kilowatt hour. We need to do that conversion again from watts to kilowatts, so we do 15 divided by 1,000 to get 0.015 kilowatts. So our cost is going to be 0.015 kilowatts times 33 hours times 9.53 cents per kilowatt hour. Our units will cancel and we're left with cents, and we have 4.72 cents. It is much cheaper to use a 15 watt